small, it will go fast. Yeah. The ratio of wavelengths associated with proton and alpha particle respectively is how much? Okay. Let's take this formula. Lambda 1 is equal to, or lambda p is equal to, you know what is that? 12.27 angstrom divided by, okay, we cannot use this, so sorry. H by root of 2m cube, right? This is the formula, 2m cube. You know this? 2m E, in the place of E, energy, we are using what? Charge into voltage. Lambda is equal to. So this is, we will write it as lambda 1, H by 2 m1 q1 v1. We will not write v1 because v1 v2 are same here. And lambda 2 is equal to how much? H by root of 2 m2 q2 v, because m2 is the alpha particle, q2 is the charge of alpha particle, v is the potential of plates. Now lambda 1 by lambda 2, they are asking what? Proton and alpha particle. Lambda 1 by lambda 2 is equal to how much? You just calculate it. H divided by root of 2 m1. m1 is how much? mp itself, right? m1 means mp itself. Okay, m2 q2, m1 q1. mp into what is the charge of proton? E, v divided by h divided by root of 2 m. What is the mass of the alpha particle? 4 mp, right? 4 mp into what is the charge of alpha particle? 2e into what is that? V. So what is getting cancelled? H cancelled, 2 cancelled, v cancelled, e cancelled, mp cancelled. So what remains there? In the numerator, nothing has remained, everything has changed. 1 divided by root of 4 into 2. 4 2s are 6. Sorry, 8. Sorry, 8. So this goes to the numerator. That is nothing but root 8 by 1. Root 8 can be written as 2 root 2 by 1, right? So the ratio will be 2 root 2 is to 1. Option number 3. 12. Yeah. Option number 3. This is actually 1 by 1. Don't forget. 1 by 1 divided by 1 by root 8. Ratio of de Broglie wavelengths of uncharged particle of mass m1 27 degrees Celsius to 127 degrees Celsius is nearly. See, this is a very tricky question. Temperature T1 is equal to how much? 27 degrees Celsius to T2 is equal to 127 degrees Celsius. The temperature rises. See, what is the relation between the temperature rising and the de Broglie's relationship? So for that you should know something about kinetic theory of gases, KGT, kinetic theory of gases in first PUC. If you are familiar with this particular concept, then you must know that the temperature and kinetic energy of the RMS velocity of the particles in a gas is directly proportional to square root of temperature T, absolute temperature T. You know that? So if this room is appearing to be very hot, it feels very hot means the particles in this room, the RMS velocity of gas molecules in this room is very high. That's why it feels you very hot. If you feel another room very cold, that in that room AC is used. So the gas molecules are having less RMS velocity in that particular room. So velocity of RMS velocity of gas molecules or average velocity of gas molecules is directly proportional to square root of the temperature. This is the known fact. This is from kinetic theory of gases, KTG. Okay, and you know the RMS velocity is directly proportional to temperature. The velocity increases with increase in temperature. So here V1 and V2 we will take the velocities. We will take the velocities are being rise. Now the ratio of de Broglie wavelengths of an uncharged particle they are asking. They are asking of uncharged particle means it has only mass m. Only mass m it has. So lambda 1 is equal to h by mv1. That is the first equation we get. And lambda 2 is equal to h by mv2, because the mass of the particle is not getting changed, only the velocity of the particle is getting changed because of change in temperature. Okay, and if v1 is proportional to root t, then v2 is proportional to root t2, then v1 by v2 is equal to root of t1 by t2. Using this equation we can write v1 by v2 is equal to square root of t1 by t2. Okay, because we have left RMS writing RMS here, but you think that RMS velocity v1 by v2 is equal to root of t1 by t2. So now what they are asking, ratio of de Broglie wavelengths. Ratio of de Broglie wavelengths is lambda 1 by lambda 2. You should write. Yeah, write it. Lambda 1 by lambda 2 is equal to, okay, h by mv1, h by mv2, h by m will get cancelled. I will directly write the relationship. Lambda 1 by lambda 2 is equal to v2 by v1. Okay, v2 by v1 is equal to, then what is that? Root of t2 by t1. Fine. v2 by v1 is equal to root of t2 by t1. So lambda 1 by lambda 2 is equal to root of t2 by t1. Got the idea? So what is t2? Remember, it is capital T. That is, there is a small t because it is given in Celsius scale. In absolute scale, it becomes 273 plus 27. How much? 300. And here it becomes 127 plus 273. 127 plus 273. So this becomes 300 Kelvin. This becomes 300 plus 100. That is 400 Kelvin. So this will be square root of 400 divided by 300. Get cancelled. Root of 4 by 3. What is root of 4 by 3? Is it there? Yeah. What is the root of 4 by 3? Root 4 is 2 divided by root 3. What is the value of root 3? 1.7 approximately. 2 divided by 1.7. So 2 divided by 1.7. 1.7 is also approximately 2. Maybe it is smaller than 2. So the value will be more than 1. Because approximately if you take this 2 divided by 2 itself, the value should come equal to 1, but since the denominator is smaller than 2, it will be greater than 1. Is there anything of this kind? 1.16. 1.16 will be the answer, I think. 13th question, 1, yes. Yeah. See, I did not have calculated, but simply I have guessed that it must be within 1.16, because 1.7 is very close to 2. 2 by 2 must be equal to 1, means the answer must be very close to 1, but there are two answers which are close to 1. 1.16 is there and 1.33 is there. 0.8 is also okay, but 0.8 we cannot take because this is close to 2, but it is less than 2. As the denominator becomes lesser, the value becomes more than 1. That's why we cannot take 0.8 as the answer. We have to take 1.16 as the answer, which is very close to 1. 1.33 is also close to 1. It happens only if this is much smaller than 1.7. Suppose it could have been 1.3 or 1.4 or 1.5. We could have expected the answer 1.33. But 1.7 is very close to 2. That's why the answer will be very close to 1. That is 1.16. This is how we guess it. Okay. Yeah. Next, a particle is projected horizontally with a velocity 10 meters per second. Velocity is 10 meters per second. It is projected horizontally. What will be the ratio of de Broglie wavelengths of the particle when the velocity vector makes an angle 30 degree and 60 degree with the horizontal? Okay, it is first initially thrown like this. Later, it has thrown making an angle of 30 degree with the horizontal. V is same. V is not changing. Another time they have taken V is the same velocity and they have thrown it with 60 degrees. 60 degree of throwing. Same velocity. Okay. Whatever be the throwing angle, we will take the horizontal component of this particular thing. Horizontal component of V is V cos theta. You know this. V cos theta here becomes V cos 30. V cos 30 means how much? What is the value of cos 30? What is the value of cos 30? Is it half or root 3 by 2? It is V divided by root 3 by 2. V into root 3 by 2, right? Right or not? And V cos 60. What is the value of cos 60? Half. It is V cos 60 is V by 2. Okay? Yeah. So this is let's take V1, this let's take V2. This is V2, this is V1. Okay. And then de Broglie wavelengths of that particular thing we have to calculate. So the de Broglie wavelength lambda 1 by lambda 2, let's calculate. That is actually h by m V1 divided by h by m V2. M will get cancelled, h will get cancelled. It will be V2 by V1 simply. What is V2 here? V2 is V cos 60, V by 2 divided by what is V1? V1 is V cos 30, that is V into root 3 by 2. V into root 3 by 2. 2 to get cancelled, V to get cancelled, it becomes 1 by root 3. 1 by root 3, that is 1 is to root 3. 14th question 1. Cos 30. What is the value of cos 30? This is correct. Point 7 by 2 means 0.8. Yeah. Yes. Cos 30 is root 3 by 2. This is 1 by 2. Correct. Silly mistake. So this would be V into root 3 by 2. V into 1 by 2. 2 to get cancelled, V will get cancelled. So it becomes root 3 by 1. This is root 3 square. 15th question. A positron and a proton are accelerated by the same accelerating potential. Positron and a proton. You see what is a positron? Positron is the antiparticle of electron. Antiparticle of electron means, what do you mean by antiparticle? Antiparticle means there will be another particle which is having same mass as electron, same charge but opposite charge. Means if E is the electronic charge, then minus E is the electronic charge, then it will be having plus E charge. Mass ME is the mass of electron, ME is the mass of positron. This is positron, POI, right? Okay, you should not confuse it with proton. Proton is a very big particle which is having E charge, but mass of the proton is 1837 times the mass of electron. They are not equal, remember. Proton is very big compared to electron. This is a proton, this is an electron. It is very big compared to electron, but the charges on proton are same. Charges on electron and proton are same. It is negative charge, which is a positive charge. But what is positron? Positron PO is also having a positive charge which is equal to E. Masses are same. Mass of the electrons are mass of the electron and positron are same. Okay, positron is different. Positron is different from proton. Remember, positron. This is electron, positron. Okay. Yes, means masses are same. Masses are same. Charges are also same. What is different here? The charge, the value there. The minus E plus E. But in the square root of the formula, the square root of h by root of 2m EV ಅಂತ ಒಂದು formula ಬರುತ್ತೆ. ಇಲ್ಲಿ magnitude of charge ಅಂತ ತಗೊಳ್ತೀವಿ ನಾವು. electron ಅಂತ ತಗೊಂಡಾಗ ಇಲ್ಲಿ minus e ಅಂತ ಬರೆಯಬಹುದು. Don't write it because if you take minus e, square root of minus becomes meaningless. It becomes imaginary. It means lambda is becomes imaginary. We probably ಹೇಳಿದ್ದಲ್ಲ ಹೊಳೆಯಲ್ಲಿ ಮುಚ್ಕೊಂಡು ಹೋಗುತ್ತೆ. He cannot give something which is counted to be imaginary. No, he has to give real results. So that's why this becomes meaningless. So if his theory is to be substantiated, then he has to take this E as the magnitude only, never the sign to be considered. So in that perspective, if you take lambda 1 is for electron and lambda 2 is for positron, see, mass of the electron, mass of the positron are same. Mass, charge of the electron, charge of the positron are same. Same potential difference is also there. I think accelerated by the same accelerating potential VV are also same. Then the ratio of accelerated associated wavelengths of the positron and the protons. Okay. They are not asking about electron and positron. They are asking about proton and positron. Sorry. Electron and proton. Positron and proton. Okay, let me make this difference very clearly. This is very good. Proton is a very big object whose mass is 137 times the mass of the electron. I will speak in terms of electron because electron's mass, positron's mass same. Charge of positron, charge of positron, charge of proton, both are same. Q. Charge of proton, charge of positron are same. That is, both are equal to E's only. Only masses are variables. So, and accelerating potentials are also same. So, in that way, lambda is equal to h by root of 2m1 e1 v1. Okay, e1 v same accelerating potential. Lambda 2 is equal to h by root of 2m2 e2 v. Okay, here e1 and e2 are not different, they are same. Potential same, 2 same, h same. So lambda 1 by lambda 2 will be, what is that, m2 remaining in the denominator, it will go to the numerator, it becomes m2 by m1, right, in the square roots. So root of m2 by m1. So what they have given is capital M is the mass of proton, small m is the mass of electron. So capital M proton, smaller m, right? Yeah. This is what proton we have written. This is what positron we have written. Charges are same, mass is smaller, mass is bigger. Lambda 1 by lambda 2, ratio of positron to proton. Yes, positron to proton is m by m, means mass of the proton by mass of the positron. That is root of capital M by m. Option number 2. Now let us start with exercise 2, level 2 questions. Matter is page number 27. Question number 11. A proton when accelerated through a potential difference of v volt has a wavelength lambda. Proton has when associated with a wavelength v volt associated with a wavelength lambda. An alpha particle in order to have the same wavelength means an alpha particle is there. This is for what? This is for a proton. And another one is alpha particle, which is to be having the same wavelength lambda. Adukku lambda ne irbekunte, same wavelength irbekunte. It must be accelerated through a potential difference of how much? It is to potential difference na acquire ಮಾಡಬೇಕಾಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ರು. Okay. Lambda 1 by lambda 2 ತಗೊಂಡ್ರೆ ಅಥವಾ lambda is equal to lambda ಅಂತ ಬರ್ಕೊಂಡ್ಬಿಡಿ, because already it is assumed that the wavelength of proton and alpha must be same. Okay, what is lambda here? H by root of 2m1 charge of the proton, that is Q1, and potential difference is same. V is equal to, not potential difference is not same. V1, let's take it as V1. Okay, V1, V2, fine. H divided by root of 2m2, the mass of the alpha particle. This is proton, this is alpha particle. So 2m2, Q2, V2. Fine? Because here mass of the proton is different, mass of the alpha different, charge of the proton different, charge of the alpha different, potentials are also different, that we don't know. H get cancelled. So it becomes root is also get cancelled, because 1 by root of something is equal to 1 by root of something means root also will get cancelled. Root 2 will also get cancelled. So remaining thing is m1 q1 v1 is equal to m2 q2 v2. We wanted to calculate v2, right? Yes, we wanted to calculate v2. v2 is equal to what? It becomes m1 q1 v1 divided by m2 q2, right? m1 q1 by m2 q2 into v1. This is the value. Yes, we will solve it. Mass of the first particle, what is the proton? Proton's mass is mp. We will put it like that. Charge of the proton is e. Okay. Mass of the alpha particle is 4 times mp, because alpha particle, you know, is a pack of 4 particles, 2 protons, 2 neutrons. And in them, neutrons are uncharged particles. Only protons have charges. 2 protons, 2 electronic charges. So mp, e cancelled. 4 2s are 8. 1 by 8 is the answer. So v2 is equal to v1 by 8. Is there? Yes. Option number 1, 11. Option number, yes. Option number 1. V by 8 volts. We have taken it as v1 by 8. Okay. 12th question. An electron of mass m, and charge e initially at rest, okay, gets accelerated by a constant electric field E. So electron was there, it is placed in a constant electric field E. Electric field E is not energy, it is electric field. The rate of change of de Broglie wavelength of this electron at a time t, ignoring relativistic effects is. Okay, this is out of your concern. Relativistic effect means if the particle is moving almost very close to the velocity of light, very close to the velocity of light, very close, then relativistic effects will used to come. Means then the mass will not be same as the regular mass, length of the particle will not be same as the regular length. Time will also not be same for us. For the relativistic motions, the time will also, the clock will also go slow. Okay, for if we spend 10 years here, then the person who is moving in velocity of light may spend just 1 or 2 months only. Okay, like that means 1 or 2 months for him will be like 10 years for us. So for him the clock goes very slow. So such effects used to come in relativity. Don't think that electron is moving with such terrible velocity, he is asking. So don't put relativity here. Using the concepts that you know, you can manage this question. That's what they are asking. Okay. So what we have to calculate is the rate of change of de Broglie wavelength with time. See, they are asking for d lambda by dt. Change in the de Broglie wavelength with respect to time they are asking. Okay. Before come to that, we should write lambda in terms of t, because they are asking for differentiation of wavelength with respect to time. Means we have to put lambda as a function of time. We have to write lambda as a function of time. Means we have to represent lambda in terms of t. That is our purpose. If you do like this, then this thing can be solved. Okay, they are asking for this. We must know what they are asking. Okay, electron is at rest. Electric field is applied. What happens to the electric charge? It will be accelerated. So let A be the acceleration of the electron. So acceleration will be acceleration of the electron means electron changes its speed. So what is V is equal to U plus AT. According to this equation, velocity, final velocity of the electron is V. Initial velocity of the electron is U, that is nothing but 0. Plus acceleration of the electron, you don't know, that into time. Okay? Yes. What is A here? What is A here? A is the acceleration of the electron. According to F is equal to ma, A is the acceleration, A is equal to force by mass. Here mass of electron means me. Okay. What is force? Force is the electric force which is pulling the electron. Here electric field into charge is called electric force. According to this equation, do you know this? Do you know this? Electric field is electric force acting for unit charge. Remember this. Here the charge is electron itself. That's why it becomes F by E, or F is equal to EE. EE by ME. This is the acceleration of electron. So V is equal to, in the place of V, you can write EE by ME. Okay? EE by ME. And into time is there T. V is equal to AT. In the place of A, EE by M is there. In the place of T, T is there. Okay? Yeah. Afterwards, what we do? We will write the equation for lambda. Lambda is equal to H by MV, right? ME into V. So what is H? H is H. ME into V is EE by ME. Fine? Into T. Correct? EE by ME into T. MME cancel. So what remains for lambda? What is there for lambda? Lambda is equal to, I will write here, lambda is equal to H divided by EET, right? EE into T into E into T. Means H is a constant, E is a constant, small e is a constant, T is the only variable. It means lambda is inversely proportional to 1 by T. Okay, fine. We will leave. This is the function of time. We have got an expression for this time. Lambda is equal to a function of time. That function of time is inversely proportional to this. Okay. It is just like we will put it as K by T. Okay. We will put it as K by T. What is K? K is H by E. Okay. For us, for our understanding, lambda. D lambda by dt. You do this according to differentiation. Differentiation of lambda with respect to time, that is 1 by T. It becomes minus K by T square, right? What is the differentiation of 1 by T? Minus 1 by T square. So minus K by T square becomes minus, what is K here? H by EE into T square. Is there? Minus H by EE T square minus H by EE T square. That option is there. 12th question is there, right? 12th question. Option number 1 is there. Yeah, option number 1. Correct? Yes. D lambda by dt. Okay. Next question. If the velocity of a particle is increased 3 times, the velocity of a particle is increased 3 times. Velocity is increased 3 times. V2 is equal to 3V1. Then, and percentage decrease in its d probability. Then how much? Percentage decrease in d probability. Lambda 2 is equal to H by MV2. Okay. Okay. H by M into 3V1 it becomes. Okay. Yeah. V2 is equal to 3V1. Now this will be, why don't we do it like delta lambda by lambda